Welcome back, folks. We're going to look at our first problem where we start to find the Thevenin equivalent circuit. I'm going to break this one into 4 videos. Oh, 4 videos. It's easier than that, but there's a lot of choices you can make, and you got to make the right choices when you're finding these equivalents. So I'm going to break it up into smaller chunks. Otherwise, it's going to be like a 45-minute video. Nobody wants that. So I have a problem that I like to use to introduce Thevenin's theorem, finding the values for Thevenin's theorem, and it looks like this. And I am going to abuse this problem for the next at least 4 videos. I'm getting picky about somehow my line didn't copy over. Okay, we have some load and we have some fixed circuit. And I want to take this fixed circuit, it's not going to change, and I want to make it look like the Thevenin equivalent circuit over here. So in order to do that, I need to find some values, and a lot of people get hung up on steps, which I think is just funny. So I find these steps to be kind of amusing, to me at least. Like the steps to Thevenin's theorem is like find the voltage and then go find the resistance. That's all it takes. There's a lot of details in how to do that. So I'm going to break it up into 4 videos, and you're saying, hey, there's 2 steps, why not 2 videos? Well, that's because when you find the Thevenin resistance, there's actually 3 methods. And I every year I have a debate on which, if I only had to teach you one, I'm going to duck which one would I teach. And I think there's value in knowing all 3, and I'll tell you what that value is as we go through those videos. What I'm going to focus on in this video is step number 1. Find the Thevenin voltage for starters. Okay, so we want to figure out what this voltage is. All right, so let's get at it. Find the Thevenin voltage. All right, let's just use the abbreviation, the abbrev. Okay, find V Thevenin. Start with that. Okay, so what we want to do is remove the load if it's drawn. It's not always drawn. Okay, in this case it is, this RL over here. We want to recopy the circuit, and we want to take that component out of the circuit. Sometimes, if you're taking the FE exam or you're going through some textbook problems, you'll find a circuit that says find the Thevenin equivalent between nodes A and B. And I think the idea there is that I know the idea there is that you're going to connect the load to nodes A and B. So it's already drawn with the load removed. This one has it. I'm going to mix it up so you see both. So just get ready for that. And rather than redraw it, because I'm lazy, and I know that you don't want to watch me redraw circuits, but you should redraw it. Okay, I'm gonna copy this over, and let's clean it up a bit for you. Okay, as much as we can. Maybe I should have done this before. How's everybody doing? What's the weather like? When I'm recording this, we're about to get a tropical storm. That should be fun. We'll see if we still have power. Okay, remove the load if drawn. Ready? It's as simple as that. And then the next thing we do, okay, remove the load if drawn, find what we call the open circuit voltage. Okay, so where that load was connected, we come back over here and we say, well, let's call that plus and this minus, and we're going to find V open circuit. Okay, I opened up the circuit and I find the voltage across it. This does some weird things to the circuit analysis. We've got a mesh here. This kind of happened in superposition when we were looking at some of those problems. We've got a mesh over here, but we don't have any mesh over here. But we still have this resistor, which is a bit odd. So we'll look at what happens with that. But this is the first step. We restate the problem. We remove the load if we need to, and then we find the voltage across where we would connect that load back up. Okay, so let's do that. do it any way you want. If you're comfortable analyzing this seat of the pants, go for it. If you're not comfortable, then maybe think about doing mesh or nodal analysis, but things get a little goofy when you start ripping components out. Okay, so I'm looking at this, and I'm going to say it's going to be 8 volts. Let's see what happens. Okay, so I've got one mesh, right? Let's call that I. I'm going to go up 12. Well, let's do this. Well, I'm going to go up. Let's do the shortcut. Let's do the shortcut. What does I touch? It touches a total of 9 ohms. We're going to invert that. We're going to multiply it by the right-hand side, which is 12. And what are we going to get out of that? We're going to get some goofy fraction. And that's going to be equal to I. Okay? Okay, so that's going to be 4/3, right, of an amp. Okay. But I want to find V open circuit. And V open circuit's out here, and it's connected to this resistor that's just kind of hanging off. I call it a wire to nowhere, which I keep saying that's going to be the title of my autobiography, just wires to nowhere. Anyhow, so we know the current flowing through it because it's not part of a closed loop. There is no current, and therefore we know the voltage across it, and it doesn't. And it's 0 volts. So don't get hung up on the polarity because it's 0. Okay, so if that's 0 volts, and I want to find this voltage. Now this voltage is across an infinite impedance or infinite resistance. I haven't talked about impedance yet. So we can't really use Ohm's law. It's 0 amps times infinite ohms. That's not going to give us a reasonable answer. So we have to go back to our fundamental laws. If we can't use Ohm's law and we're looking for a voltage, then we should probably use KVL, and that's exactly what we're going to do. So I'm going to find this voltage here, and say this is VR2. And we can find VR2, well, let's see, I touches it, and it goes in the positive direction. And then we multiply it by R2. So it's going to be 4/3 of an amp times 6 ohms. And that's going to be 8 volts. Okay, but that's the voltage across R2, and that's what I quickly did in my head, and I said, hey, V open circuit is going to be 8 volts. And here's why it's 8 volts. So let's take that. Since I have a lot of room up here, let's move it up there. And let's write the KVL around this path on the right. So I'm going to go up VR2. I'm going to go down VR3. And I'm going to go down V open circuit. And I'm back to where I started down here. Right? So let's get that drawn in for you. So I'm going around here. I'm writing a KVL around that loop. Okay. And I'm back to where I started, so that's equal to 0 volts. So if I go up 8, I go down 0, and then I bring V open circuit over to the other side, we can see that 0 drops out. Okay, then we have V open circuit is equal to 8 volts. Okay, so now that open circuit voltage is related to Thevenin with the most complicated formula that we're going to have all semester. So get ready for this. You can handle this, I promise you. Thevenin is equal to V open circuit. All right, I lied. That's it. Okay, Thevenin is equal to V open circuit. A lot of times we talk about it, instead of just labeling it Thevenin, we talk about it as the open circuit voltage so that you don't lose sight of the fact that we open up the circuit and we find the voltage across it. For this circuit, I want you to tuck this away in your head. For this circuit, that Thevenin voltage is 8 volts. Okay, so this is another important result because we're going to, over the course of the next videos, we are going to we're going to forget that, honestly. But at the end of this series, we want to use that 8 volts to build the Thevenin equivalent circuit and see that it is in fact equivalent. We're going to get the result from the original circuit, and we're going to get the result from an equivalent circuit, the Thevenin equivalent circuit, and they're going to match. Okay, turns out Thevenin knew what he was talking about. Okay, so that was, hey, that was step 1, right? We're halfway there. We're totally not halfway there. There's a lot of different, there's 3 different ways to find the Thevenin resistance. There's appropriate and inappropriate times to use each one, and I'll do my best to make them short, but you're going to get 3 videos finding the same value, and that's what's coming up. Okay, same problem. Don't forget this. I might even just steal that right off there. Stay tuned and good luck, folks.